First we will link the conrod to the piston and then link the piston to the sleeve. If we move the piston, you will see that only the conrod and piston move. If we move the sleeve, we will see the whole assembly move. This is a good check to see if our objects are linked as we would like. We will now activate the inverse kinematics icon. We can then select the hierarchy button. Finally, we will open the sliding joints roll down menu. If we select the sleeve, we can then deactivate all of the sliding and rotational joint parameters. We can see then that if we move the piston, the sleeve will stay stationary. If we select the active radio buttons for the piston, in the sliding menu we will see that the piston can still move freely in all directions. If we now turn off the X-axis and Y-axis active radio buttons, we will see that our piston will only move in the Z-axis, which is still active. In the Z-axis, we will select the limited option and then adjust the from and to spinners. We will be able to constrain the movement of the piston between these two parameters. We can see that the piston will only move to the limit we have just set. The ease option causes the joint to resist motion as it approaches the from and to limits. The spring back option is a force which is trying to bring the conrod back to its rest position. It is as if a spring is pulling our conrod back. The spring tension option sets a value for the strength of our hypothetical spring. The higher the value, the stronger the spring. The damping option simulates friction between the moving parts over their whole range. Again, the higher the value, the greater the friction or inertia force.